Welcome to my presentation. My name is Andreas Heim. The presentation is called Notorious B.I.G. Data, Wins and Fails when Building a Big Data Platform in the Cloud. So first off, let me introduce myself. My name is Andreas Heim. I'm the VP of Engineering, first employee at Unacast. I got around 15 years of experience with software development, like big data, NoSQL, stuff like that, working as a consultant in Oslo for many years. Currently live with my wife and 2 kids in Brooklyn, New York, beautiful neighborhood called Park Slope. You should all visit if you're there. Keep in mind my apartment is a bit small, so don't visit me, but visit the neighborhood. So I work at this company called Unacast. We're a small startup, and we call ourselves the global #1 human mobility data platform. And we create something that's called the real-world graph, which kind of describes how people and places are connected. We're selling this product into ad tech, to martech, finance, retail, hedge funds, research companies, and supporting their data-driven decisions. We have around 25 plus paying clients, and have gone from 0 to multiple millions of dollars in yearly revenue over the past 3 years. We're a Norwegian company, but we quickly opened an office in New York, a sales office. We're around 40 people with a 50-50 split between New York and Oslo, with Oslo as the main hub for developers, and New York is the main hub for sales, marketing, and product. Our clients and data is US only, so we are kind of a global-ish company with offices in 2 locations. So I've been talking about this thing called human mobility data, and I think that's really important for you to understand for the rest of my presentations. I'm going to talk a bit about human mobility data. So in essence, human mobility data describes how people move around in the physical world. And there's a wide array of use cases for data-driven decisions. In itself, a single data point is not very valuable, but as it only describes that something happened, but not what happened or why it happened. It's when you kind of start aggregating multiple data points and add context to that information is when you kind of get the real value and the interesting things start to happen. So this is kind of a very simple illustration of our data model. The data points that we receive is only describing that a device, like a cell phone, we're at a certain place at a certain point in time. But when you start looking at multiple data points and aggregating and looking at patterns, you can start to make assumptions on what happened. For us, our finished product, and what I'm mainly going to talk about today, is the visit product, which is kind of an aggregate over multiple location data points, which creates an event with context attached to it and kind of insight to what happened. From a theoretical point of view, we start out with precise location data describing a single device. And then we need to identify whether the device is stationary or whether it's moving. And for that, we use some clustering algorithms to identify that behavior. And after that, we can use our point of interest information, or POI as we call it, to find out what is the most likely place that the device visited. As you can see, the device we look at here had 2 visits that we were able to attach point of interest to. In addition, it had 2 stationary periods where we weren't able to assign any context, and that could, for instance, be that the owner of the device was waiting for a green light, or being at home, or like parking his car or something. And I also want to dive somewhat deeper into the process of actually assigning a POI. So here you can see a more detailed picture of a potential visit. And as you can see, there are a lot of different venues nearby the potential visit. And this is a mall somewhere in America. To figure out the probabilities of a device visiting a specific place, we need to look at many different properties, mainly the distance to the venue and the footprint of the cluster of data points. But we could also look at opening hours, type of store, and previous behavior for the device. And that's, in essence, human mobility data for us. This is a small slice of our product, but for this presentation, this will suffice. Now that you have that background information of human mobility data and kind of what it really is, I want to give you some insight into how we've been working over the last couple of years, and to understand some of the choices and some of the mistakes that we have done. So there's also some prerequisite information that is useful. So Unacast isn't your regular product company. Our user interface is Amazon S3. Our product is data file. And Unacast acquires location data through data partnerships. The data is delivered to us through file also in S3. Our partners send data to us at different cadences, like ranging from once a day to multiple times a day. And all our data is late and out of order. So that's where the interesting challenges begin. Okay, so we're going to take a small retrospective and see kind of where we started out 3 years ago when I joined the company and where we are now, just to give you guys some context. So December 2015, after 3.5 months of my career into Unacast, we had a proof of concept launch with a Norwegian cinema chain. The use case was retargeting people who had visited cinemas. We had around 100 rows of data per day, and like 8 or 9 daily active users. We could fit all our data in a small notebook. We could basically just write down every single data point that came in. Today, we have a mature product in the market with, as I said, 25 plus paying clients. And the use case is supporting data-driven decisions with human mobility data. We ingest around 3.5 billion data points per day. We have around 30 million daily active users, and we have 200 million monthly active users. So with that in mind, there has been some changes in our architecture, and that's what I'm going to talk about today. So October 2016, we'd found the first signs of product market fit from our visits product. We prototyped a bit back and forth using BigQuery. And when we launched our product, it was basically just SQL. SQL scripts running in sequence. So BigQuery, for those of you who aren't familiar, is a column-oriented hosted data store on Google Cloud, which you can kind of throw almost anything at and will like scale infinitely. At this stage, we're only dealing with pre-assigned POIs. We receive point of interest information from our partners, making the architecture a bit simpler. So we only need to kind of cluster the data points to create the visit. And we spent some time kind of refining the engine, running this, all the scripts, but basically it's just a super thin layer on top of Kubernetes running SQL script in sequence. It was the simplest thing that we could, that could possibly work. We went full on into the market selling that. So to summarize, maturity, first signs of product market fit, architecture, SQL running on BigQuery, volume around 100 million rows per day. So the pros of this architecture is that, of course, it's super simple, right? It's almost, you can almost not call it an architecture. It's basically just SQL, fairly efficient and fast. The cons of it is, of course, it's SQL. It's a nightmare to maintain. And kids don't write clustering logic in SQL. That's a very bad idea. And we recalculated our entire universe every single day, which basically wouldn't scale if you sat down and thought about it for 5 minutes, which we didn't. All right, so let's fast forward. This architecture lasted for a bit more than 6 months before we start seeing problems with it, basically. At this point, we've evolved a bit. We've improved our load jobs of data coming in using a Rube Goldberg machine of Lambda functions, PubSub, Google Cloud functions, transfer APIs, which is a topic for a different presentation about stupid ideas. So the status is that our way of recalculating visits every single day simply doesn't scale anymore. The time it took to run our job, start creeping towards the 5-hour mark, which makes it really bad if something goes wrong, because then you're looking at another 5 hours to get your product out to your clients. From an economical point of view, it's kind of starting to creep up the costs, and from a maintenance point of view, it's not really good either. We've also done some R&D into improving our clustering algorithm, moving us a bit away from BigQuery and SQL for the clustering part. And after a very brief discussion, we said, like, we have to rebuild this thing. I initially estimated it to be 3 days. Turned out it was 3.5, 4 months, which I'm constantly being bantered about at Unacast. And we moved over to batch-wise creation. So every time we received a batch of data from one of our clients, we calculated visits for that batch. And we wrote that in Dataflow, which is a hosted kind of Spark-ish framework written in Java, which is pretty cool, and you should check it out. So the new architecture is we load data from BigQuery still, and we have Dataflow read from BigQuery. All the data is loaded into memory. And since we're looking at device-level data, we do a group by key as kind of the first step, and then we apply our clustering logic after that. This is pretty efficient and quick at this point in time. It requires some machines, of course, to make it work. But and to our grand surprise, it's a bit more expensive than the previous way of doing stuff. But we still kind of kept on doing it. In the same change, we also started to assign our own point of interest, kind of making it a bit more complex. But of course, a huge improvement to our product. And to facilitate this, we needed a scalable way of querying kind of geospatial data. So we created a small API running on Kubernetes with a MongoDB sidecar container, so it could kind of scale linearly. And the service was kind of hammered when we processed the data to assign point of interest. But we had a new shiny pipeline. It's big wins. So let's look at the pros and cons of this one. So the architecture is pretty straightforward because you kind of encapsulate everything in one component, the data flow jobs. It's much faster than the previous system. Deployment is super easy, and we can finally test stuff. The cons of it is, like, the performance is slightly exponential. So if you kind of throw double the amounts of data, it takes a bit more than double the amount of time and double the cost to fix it, which obviously isn't good. And then it's way more expensive, and we started scratching our heads, and this wasn't the intention of what we really wanted to do. So if we go kind of to present time, having volumes of data grow month over month, our shiny new pipeline started bursting at the seams, and we were faced with some of the same issues that we had with our old SQL pipeline, but mainly related to cost. And that's a bit sensitive topic. So present day, we have around 3.5 billion data points every day and growing. Performance is okay, but not as good as we want it to be. And the costs, I mean, our VP of Finance isn't my best friend, to say the least. So in between of the release of the Dataflow-based pipeline and present day, we've also done some changes that's most notably starting to create visits on a cross-partner level. So remember, we have multiple partners delivering data, so we can kind of exploit the aggregator position and kind of look at data from same devices but from multiple partners, which is a huge improvement to our product, but is making this very expensive. We also saw that our approach was a bit naive at best by doing the clustering and the group by key in memory. When we started to really dig in and analyze, we saw that this is the group by key step that's actually like putting the most pressure and most time-consuming and the most expensive step. So again, it's time to redesign. This doesn't make our product guy happy because he wants to push out new features, and I'm saying we have to rebuild the pipeline. So both the VP of Finance and the VP of Product is mad at me, which isn't a good thing. So this has led us to our new architecture that we're currently implementing. And we call it Group by Key as an internal product, which is a fancy name, marketing not involved. in that one. And we're kind of beating ourselves up for not understanding this earlier. And in hindsight, this is the most obvious decision we should have made a year ago. So to give you a breakdown, this is kind of how we design our new pipeline. So first, we load the data into BigQuery. Everything happens in BigQuery at Unicast. And from there, we do a group by key in BigQuery, which is a good idea. And by doing this step in BigQuery, we were also removing like 95% of the cost of the group by key step, which to us is a big deal. And secondly, we read the group data from Dataflow and apply the clustering logic from there, which makes sense because you don't want to, like, remember, you don't want to write clustering logic in SQL. And then again, we output it to BigQuery as kind of just a cluster without any context, and we add the POI information also through BigQuery. By doing the POI lookup in BigQuery, we can eliminate our POI database and remove costs from the Kubernetes cluster, which is a big win. And actually, the cost savings from just the group by key enables us to hire 2 more full-time employees at Unicast over the course of a year. But even more importantly, we can start offering the group data as an internal product for reporting, other products, and kind of a whole wide array of use cases internally which we can use this for. So to summarize a bit on the new architecture, like the process is super efficient. It's actually pretty cheap. We're talking about like multiple terabytes of data per day here. It's pretty modular, so you can kind of mix and match a bit where you want to put stuff in. And the cost structure is near linear. We're hoping to get it sublinear, but that's for the next architecture. The cons here is that the complexity is a lot higher because you have multiple components having to talk to each other, and small changes can kind of trickle down and influence potentially every single thing downstream. But all in all, it's kind of the architecture that we should have had a couple of years ago. So we've obviously been around the block and back. We started out small and simple, went in a somewhat correct direction, and then decided to turn around, go backwards, and do things properly. And even looking back at this now, I feel like the decisions we made at the time we made them were kind of fairly correct. And there's some things that we have done. I mean, like building a tech company from scratch isn't just architecture. It's about more than that. And we have done some things that were pretty smart in hindsight that kind of enable us to discover these things and actually make improvements continuously. So for us, it's all about the product teams at Unicast. If the team making the visits didn't have the mandate to make their own decisions, we'd be stuck at square one. So teams at Unicast, they have their own roadmaps. They choose their own tools and languages, choose their own internal processes. We have clear interfaces between the teams, and a company roadmap is more like a democratic exercise than anything else. And that's kind of it's kind of the building blocks of what makes us us and what makes us able to kind of move fast and kind of identify problems early. And we have kind of a small set of philosophies around technology. We try to have as few as possible because in my career I've seen that the more philosophies you have, the more restrictions you put on yourself and your team. So our philosophy is basically don't be religious. Technology is just a tool. It's just a means to an end. Perfection is the enemy of good. So ship it early and ship it hard. And of course, as any modern company, you go directly to the cloud. Why wouldn't you? If anyone disagrees, I would love to talk to you afterwards. And you have to fail early. You have to understand when you fail, both in terms of architecture, in terms of builds, in terms of products. You need to fail early. So going to wrap it a bit up. If you can start out small, do so, but be aware of the limitations in your architecture, so you can be a bit proactive and rewrite it at the exact correct point in time. If we were to have built what we're building now 2.5 years ago, we wouldn't be where we are now. Because then we would spend too much time actually building the stuff. We're a bigger team now, we have the bandwidth to do it, but we didn't back then. So we needed to hack something together and do it as quickly as possible. Simplicity over creativity is always the better thing to do. If you can keep it simple, do so. We know we all love to polish code and make architecture sweet, but like simple does it. And I mean, sometimes a hacky solution can help you validate your product and get quick into the market, which is super important for us as a venture-funded startup. We have limited runway, and we need to kind of get to where we're supposed to go fast. And when you're maturing, at least when you're building kind of a data pipeline, it's important to try to identify the small building blocks, which is kind of where we failed a bit. The building blocks of your pipeline. We realized too late that our bottleneck was the group by key step. So don't make our mistake, because we'll jump up and bite you in the ass. I have 2 bonus learnings, because I know it's lunch and you guys want to eat lunch. The first one is moving large files over the internet is really hard. It's one of the problems that we spent the most time on fixing. Moving 10,000 files at once over the internet is even harder. So if you want to talk about moving files over the internet, ping me. I will give you some learnings. We have a lot of time for questions or lunch.
You said you had clear interfaces between the teams.
Mm-hmm.
Could you explain more about that? What it means?
Yeah, so the question is, so that clear interfaces between the teams. What do I mean with that? So basically, we try to have our product teams deliver products, even internal or external. And for Unacast, our product is data. So the interface between the teams for us is basically a database. Like, it's not an API, because that wouldn't scale. So that's what I'm talking about, interface. Did I answer your question?
Yeah.
You sure? I'm all ears for more questions.
You said that the roadmaps are a democratic process. Can you explain how you do that in practice?
Yeah, so it's about roadmaps as a democratic process and how you do that in practice. Since we have cross-functional product teams at Unacast, like the teams themselves know what should be on the roadmap for their team, for their product. So the team that creates the visits also has salespeople out in the market understanding where the market is moving and what we need to add to our visits product or improve to make it work. So basically, our kind of roadmap process is to source internally from the teams first and come up with a prioritized list over the things that the team wants to achieve. And that kind of makes it very easy, because they have they have first-hand insights into what should be on the roadmap and what needs to be in the product for the product to be where it has to be in like 6 months. Of course, you need to look at this from a company perspective, because if you have one product that has more revenue than the other product, you need to make sure that you're kind of prioritizing correctly. So that's sort of a democratic exercise where you come up with a list of roadmap items for each individual team, and then you take all the team leads and stakeholders in the teams into a meeting room and you battle it out to figure out what's the more important thing for a company, for the company as a whole.
When you have different teams using different tools and so on, having their own decisions on what platform or whatever, how do you kind of gain synergy from the teams and kind of don't reinvent the wheel every time?
Okay, so the question, let me try to summarize. You have multiple teams working independently, choosing their own technology and their own tools. How do you prevent them from reinventing the wheel? And how do you create synergies between the teams? Is that correct? Yeah. So that's one of the harder things with product teams and autonomous teams, is that you will have duplication. that's kind of the price you have to pay. Of course, you have to make sure that no one's creating the exact same thing. We're trying to foster a culture internally where you kind of share some of the tools and some of the learnings that you worked with. People, kind of the crosstalk between the teams. If someone does something cool with Airflow, another team will kind of pick that up and look at it. So I guess kind of it's a trade-off between like controlling everything from the top and deciding what everyone should do, and instead having it bottom up. So it's of course a trade-off. There are a few things in our architecture which are similar, kind of doing the same thing. We have kind of two systems moving files. They're moving in and out, and then kind of different properties as well. So we've had discussions of kind of merging those two systems, but they're made for two specific purposes. So even though they, on the surface, do the same thing, if you dig a bit deeper, they really don't. So I guess what I'm trying to say is that if you divide your teams more or less correctly, that won't be an issue. You would still have some duplication. For instance, one of the downsides of this, we don't have any team owning our deployment pipeline, right? Which is an obvious bad thing. But still, there are more kind of advantages of having the teams move fast and independently than to make sure that they're using the same tools or the same languages. All right, if there's any more questions, you can just find me on the internet or talk to me afterwards. Kid. All right, thank you so much, everyone.